Hi, it's Nicole, and I'm here to talk to you about global wind patterns. Global wind patterns affect our local weather from the Earth's equator being closest to the sun than any other area on Earth. The poles are the farthest area from the sun, meaning they get the least amount of heat, while the equator gets the most amount of heat. The equator's heated air rises into the atmosphere until it stops rising and starts spreading into the north and southern poles, about 2,000 miles into the air. A low-pressure area forms at the surface of the region of clouds forms a altitude level. A global wind pattern carries two types of air masses, warm air mass and cold air mass. The warm air mass and cold air masses can confront one another and create something called a front. There are four types of fronts: warm front, cold front, stationary front, and occluded front. A warm front is the surface boundary between a warm air mass and a cold air mass. It's overtaking. The warm air mass moves into an area of colder and drier air. The air masses do not radially mix, therefore the warm air rises slowly over the cold air because it is less dense. This produces clouds and precipitation well ahead of the approaching warm front, since the warm air in the southeastern U.S. usually has higher water vapor content than cold air. Steady precipitation persists along the boundary of warm fronts. This amount of precipitation, however, depends on the amount of moisture in the air ahead of the surface front. If the warm air is dry and stable, precipitation would not be likely to occur. If the air is moist and unstable, heavy precipitation could occur over a broad area. A cold front separates a cold, dry mass from warm air masses. The cold air mass pushes under the warm air mass because of a higher density, forcing the warm air masses to rise. If enough moisture exists in the atmosphere at this time, then clouds could thunderstorms could develop.